Yes, this one. Can you look at this?
Yeah, it's good. It's good.
Okay. So today's my topic is geotechnical engineering for high-level radioactive waste disposal project in Japan. But as you know, so United States and India also have this project, but a little bit different. But from the viewpoint of some geotechnical engineering and civil engineering, I guess. Oh, right. I guess that it is very.
Yeah, go ahead. Sorry.
All right. I will telling you that some geotechnical engineering and civil engineering will be what to say, so highly contributing to solve this problem. And this problem is not only not only Japan, maybe all of the world, I think. And please, I hope that everybody are interested in these issues for, I think, human race, I think, okay? And have already, Krishna introduced me that and I'm now a professor of the Waseda universities. And maybe Waseda University, you know, so Waseda University is one of the largest private university in Japan. And what I say, and a very long histories universities. And actually, very excellent students are now growing up in this universities. Okay. So, and if possible, and if have some time to Japan, come to Japan, so please call me, and I will guide what's the university areas. Okay. So, and next. So today's my topics, content of my topics is firstly, I will talk about the situation of the nuclear power situation in Japan, especially so that it's as you know, so the 2011 years, so Japan have a very terrible serious natural disasters, yes, serious earthquake damaged. So, and before 2011 and after 2011, it's a little bit different. But I will explain a little bit like that. Okay, and the next I will talk about the background of this research, and after then, of course, today's this webinar topics is geo-environment. So, and in this project, so there are a lot of the geo-environmental subject. Okay. Moment. Oh, sorry. And this one. Okay. So I will check. Also, can you hear me?
Yeah.
Right?
Yeah.
Okay.
I can hear.
And the next one is and I will explain some briefly our research subject. And finally, so I will conclusions, and some I will show you that some photo gallery for the near futures. It's a very excellent civil engineering facilities. Okay, and by the way, so I'm not talking about. I was talking about some 2011 is a very one of the milestone years, I think, and after 2011. Maybe as you know, some Fukushima Daiichi nuclear NPS nuclear power stations have serious damaged, and Waseda universities are leading this project, JGS project, Geotechnical Application and Education Initiative to the recovery of the nuclear power plant accident. Also, this project is we have to collaborate with nuclear engineers. But today is not so much time to explain. So, but maybe, some show that some slides. So like that, you know, Fukushima Daiichi NPS is a very serious problem, and still now continue to these situations. But of course, are improving this years because about 20 years spent. So but actually, so we have a lot of the research teams and R&D teams for solving this Fukushima issues. And Waseda University are now leading to this project. But today, I have no time to explain. Sorry. So and if next time, so I will explain these topics. Okay. And today's my topic is nuclear power. What I say? So not accident. So general generating some energies by the nuclear energies issues. Okay. So and firstly, so I will show these figures. Yeah. Firstly, so please look at this. So, United States is the top numbers of the nuclear power stations in all over the world. And France is like that. And Japan is the third one. And actually, so this data is at the 2004. So 20 years ago. Yes, almost 20 years ago. And like that, some Russia, Korea, UK's, and like that. And after that, I will explain the India and the China. I will show us some data. Okay. And this one is a 2018. Yes, after 2011. We have a accident. So but now like that. Okay. Yes, around the 2018. So around 5 years ago. So China data is we can find like that. So and so I guess that so some participant is from China. So and it's also what I say. It's a very it will be this problem will be not only in Japan, in China also like that. Okay, and this area is some European areas. Yeah. So and also is this issue is very all of the world issues like that. And this one is relatively brand new data. China is maybe China will be a top countries of this of the nuclear energies areas. And India, as you can see, so India is like that. Okay, maybe it's a planning now. So and maybe 2 or 3 years later, India is like that. Here is like that. And Japan is like that. And this is what I say. So we are now. So government have some problem to what I say. It's very difficult to decide to which ways. So and now in Japanese schedule planning, it's a very both sides. So what I say. So the increasing the nuclears and decreasing the nucleus. So government have not yet to decide to the which way is better like that. Okay. So and I want you to tell you that some this nuclear radioactive waste disposal project is maybe all of the world issues, I think. And after that, I will talk about this project. So what I say, so many civil engineering and many geotechnical engineers can be contributing to solve this problem. Okay, so and please interest these issues. I hope. Okay, for the futures and human race. Okay. And now in Japan, government are now planning this nuclear fuel cycle systems. Okay, so maybe some person knows that some Japan have not so much energy resource. So on the nuclear energies is a very what I say familiar, yeah, but very convenient to use. Yeah, because if we can get some fuel and some energy resource, uranium, so and we can Japanese engineers can be generate some power by using some uranium, and but after them, so nuclear power stations generating the powers and use fuel some recycling like that. Okay, but this system also exhaust some radioactive waste, not only the high level, low level, and transuranium like that. And actually, so engineers have to make some very good answer to solve this problem. How to treat and how to dispose the high level radioactive waste. Okay. And actually, so this issue is, I guess that maybe only the civil, only the nuclear energies cannot solve this problem, because actually, so we have to construct some very large civil engineering facilities. So and also, so nuclear engineers think about some not only the nuclear engineering, so and civil engineering and especially some geotechnical engineering is necessary to solve and nuclear power, nuclear energies understanding. So and we are now collaborate, yes, with nuclear engineering and geotechnical engineering and civil engineering. Okay. So and so firstly, so kinds of the radioactive waste. Yeah. Some people think about me that some Komine is a nuclear engineers. Yeah, I'm not nuclear engineers. So I must also so civil engineering engineers and geotechnical engineers. Okay, and actually, so I will explain some kind of the radioactive waste, high-level radioactive waste and low-level radioactive waste, and transuranium waste. So and firstly, so we can understanding the kinds of the radioactive waste. Yeah, maybe as you can imagine, some high-level radioactive waste is very dangerous. So highly decaying and highly radiation generating. And the low-level radioactive waste is not so dangerous. So, for example, some the workers the workers who are staying in and working in some nuclear power stations areas, the clothes and washing some material, those are the low-level radioactive waste. But and actually, so almost no radiation. And actually, so in UK, for example, some in UK, so that low-level radioactive waste is almost same as some general environmental waste. Okay, and the trans radioactive waste is what I say, so almost not so much high radiations, but the reducing some radiation generating term duration is longer. So too longer, more than 10,000 years, like that. So and from the viewpoint of some time spending, so also summation of the radiation is very large. So TRU radioactive waste is almost same as some high-level radioactive waste. Okay, and actually, so yeah, from the viewpoint of some what I say, so impact. for the general general environment due to some kind of the radioactive waste. Yeah, as you can see, this is all. It's you can make some image, some civil engineering issues like that. If the very relatively low radioactive waste is, for example, some excavating some, almost general, what to say, industrial waste facilities like that. Okay, and relatively highly radioactive waste like that. Maybe some depth is some several what I say, several 50 or 70 meter like that. No. This one is some several meters. Okay, almost around the 10 meter like that. And now in Aomori areas in Japan, so this project is now undergoing. Okay, and intermediate disposal. So this like that some 50 or 70 meter like that, and high level radioactive waste. So we usually call some deep geological disposal, so the transramen like that. This facilities is more than not maybe correctly some more than 300 meters depth. And I guess that 500 or 1,000 meters like that, we will excavate the tunnel and put on some this high level radioactive waste vessels like that. So, and as you can see, almost underground facilities. So, and actually, so only the civil engineers can be doing and can be solving this problem. Okay. Of course, so and with the nuclear engineers like that. Okay. And yes, this upper side is some low level radioactive waste LLW. We call the LLW. So this means some low level radioactive waste issue. And this is a HLW, high level radioactive issues. So, and Waseda universities have both kind of the waste to solve this problem. And but today's my topic is focusing on the HLW issues. Okay. And high level radioactive waste. So I have already said you that, but it's pictures. It's so, and I guess that it is very good. It is very easy for participant to understanding and make some image. High level radioactive waste is yes, like that. Canisters contains waste, and the waste is some by solidification, solidified by using the glass. Okay, and the diameter is about 40 meter like that, and height is 1.3 meters. 1.3 meter, not so high. Okay, but in futures, so Japan cases some 40,000 pieces of this material will be generated, and we have to design and construct that facilities on the keeping all of the waste containers like that. Okay. So, and the HLWs are now in storage for the cooling now. And firstly, some ship. And so this is a very special vessels. And actually, so sorry in Japanese explanation, but it's very difficult to show that pictures because of very high security facilities. So I will explain that. So this vessel in the HLW vessels now, and this carry from that port to these facilities. And yeah, this vessel is like this one. And firstly, moving to this like that, and picking up some containers. And after them, this facility is what I say, so one of the pool, a kind of the pools, and put on. But actually, so no using the waters pool. Yeah, we call the pool, but no waters, only the airs. Airs to cooling the airs input, and this spent fuels is now cooling by using some aerations. Okay, and actually, so that we are now planning to keep this like that for around 30 years, 30. Okay, so maybe some if some people 20 years old people, so maybe this material picking up some 50 years like that. Okay. Okay, and actually, so this yes, promotion for LW disposal in Aomori Rokasho village now. And I'm a specialist of this issue, so and we can take pictures. But from the viewpoint of the securities, it's a very difficult. I and my friends and my student can be visit this. So and if so Krishna also if they're coming to Japan, so I will guide you. I will guide you to these areas. And this part is some very high quality concrete. And yeah, it's a very now hot topics now. Maybe after maybe maybe this year's that some filling up construction, filling up project will be start in this years. And which companies are doing some. So maybe 1 week later, maybe that companies this will be decided, I think, determined. And like that. Okay. And yes, this one, yes, October last year's. Actually, so that's some number one facilities and number two facilities, and have already LW containers pieces are now disposed. And I have already said you that some in this use that's filling up and the covers by using some bentonite and sand material project will be started to do this use. Okay. So and now geotechnical engineers and civil engineers are now very, what I say, so working hardly to do the designing and the constructions. Okay. Like that. Okay. And the transuranium radiations is like that. Yeah, it's a very difficult to maybe to make some image, but this picture is better, I think. This is a fuel, or what I say, fuel. What I say, so fuel containers, very small containers, and after that, so this metals of these containers is some relatively half-life of is so long. So and it's a very take care to these spots. And so and almost TRU radioactive waste is almost same as some high-level radioactive waste. Okay. So and now high-level HLW disposal underground facilities like that. So and this is my drawings, and yes, and 24 years ago, the Japanese government decided to do to schedule this project, and what I say, so and how depth of these facilities. So decided. So and more than 300 meters, but actually so 500 or 10, 100, 1,000 meters like that. And yeah, this is all of the tunnels, a lot of the tunnels. It's a very, what I say, it's a very difficult, but from the viewpoint of some civil engineers, a very, yes, what I say, exciting project, I think. And this part is my enlargement. And this is tunnels, and also some excavating some disposal pits. And each piece is put on this like that. Of course, this vessel is a very dangerous material. So, and yes, it is necessary. It is necessary for to separate, isolate to the human race and the general environment. So, and of course, in Japan is underground waters is a lot of the underground waters. So, and underground waters cannot be touched these materials called nuclear waste. So this red part should be almost impermeable, but impermeable is impossible. So on the very, very low material, we have to develop and select it. So now in Japanese project, selected some bentonite material for as artificial barriers of like that, okay? And this tunnel is also finally so filling up by using some almost bentonite and sand material like that. So, and firstly, so we can understanding the fundamental properties of that material, and from that data, so we have to design and the constructions, okay? This is some pneumo concept. Pneumo is some, what I say, so one of the, yeah, but pneumo is, yes, yeah, top, yes, organizations of this executing this project. So a kind of some national companies like that, okay? And now pneumo are now selecting the site. So and now Hokkaido areas is some part is some one of the candidates now. And not only the underground facilities, but also some surface facilities also like that, okay? So, and yeah, it's a very large surface facilities. And after that, from this part, there are very long, very under deep shaft. And maybe it's a very difficult to construct, but like some rounding facility like that. And after then, for more than 300 meters, so we have to excavate a lot of the tunnels, okay? And after then, like that, pits, okay? It's a very, what I say, so great project in Japan now, okay? And this part is some disposal pits, okay? And this part is focusing on this, and more than, yes, 25,000 pieces now, okay, and maybe 40,000 pieces. Okay? And this is what I say. So, so situation of the nuclear waste issues in Japan now. And from now, I will background of this my research. So I have already sometimes some focusing on some bentonite. And actually, so in this project, not only what I say, pure bentonite, some sand bentonite mixtures, and some bentonite is a very interesting soil material. So the compacted, static compacted bentonite also using the buffer materials, barrier materials for the radioactive waste disposal. And this focusing on some not only in Japan, in Swedish program, and yes, Swedish program and Switzerland, Italy's, yes, European countries almost focusing on the bentonite, and there are a lot of researchers. And the United States is Yukon Mountain is like that. So and that project is upper side of that underground tables. So the barrier material requirement is a little bit different. But actually, so the bentonite is one of the candidate material, I think. And the requirement of that buffer material is a very low permeability because yes, isolating. So we have to make some longer isolating, separating time. So and very low permeabilities. And the high swelling is also required because if the as you know, some Japan in Japan there are a lot of the earthquake. So if there's some material and facilities some broken and some fissures, making some fissures, but this material is very interesting. So swelling and expanding the volume. So and this swelling characteristics can be using some sealing, very good sealing material. So and bentonite is a very good material for this project. Okay. Yes, this is a larger figures. It's like that. I have already explained this part like that. Okay. And the red part is some bentonite, compacted bentonite or some sandan bentonite material. Yeah, and this is what I say. So one of the model and very real scale models, and this is your real bentonite blocks. Okay. And put on like that. And this is the waste containers. And in Hokkaido's areas, Horonobe URL in Japan now. And yes. Okay, so and maybe you know some bentonite material like that. So and but actually, so it is better to show that pictures. Okay. I will show these videos. It's a very good videos to understand the very interest of the bentonite behaviors. Okay. Yes, I will explain that. This from now, so I will be take out some material. One of the granular bentonite material. I have selected these videos, and yeah, as you can see, some just look like some soil. Look like a soil. Yeah, it's a soil. So and after some vessel and it puts some fresh waters, and after them, it's please take care and 1, 2, 3 or like that, and putting out. Okay, as you can see, so water is coming out, and after it's needles and insert this part. Yeah, as you can see, some what I say, so completely insert in the side of the waters, but water is not coming. After them, putting out, also water is not coming. It's a very interesting, I think.
Very nice.
After after that, so I will show you some site of this this. Okay, you can use some lectures, I think. And actually, so in real, so I will show the students. Yeah, actually, so it's a very good education material, I think. Okay, it's a very so and the bentonite is very interesting. Okay, Okay, so and from now I will explain the geo-environmental subject in this project. So and yeah, firstly, so to clarify the roles of the bentonite, and sorry, and how to determine the specifications. Specification means some dimensions, size, and the material, selected material, and the density, something like that, and so on, and how to construct. Construction method is very interesting from the viewpoint of civil engineers. And yeah, this one is also very interesting. In this project, we have to consider not only the mechanical properties. Of course, we have to consider some mechanical properties, but in chemical condition is quite widespread conditions. Okay, so on the seaside, inside like that, and some temperatures are very changeable like that. Okay. Yes, and the saline waters and high temperatures we have to consider, and it's very difficult to do. But from the viewpoint of some interest of the research, it's a very widespread and expanding the researching themes, I think. Yes, disposal facility in coastal area. In Japan also, so island areas. So and we have to consider some seawater behaviors, inland waters or seawaters, and the deep facilities also. And so these facilities is coming inland waters and sometimes the sea waters. And as you know, so this nuclear waste issues is we have to consider some 10,000 years, more than 10,000 years durations. So and the sea waters and the inland waters and this water is moving. So and the facility is also changing, alternating in the water chemistry. So and the material also we have to consider how behave that material in the water chemistry condition changing like that. It's very interesting. Okay, from the viewpoint of some researchers. Okay, and the role of the buffer material. Okay. And the role. Yes. First, role of buffer material is we have now selected a very low permeability, self-sealing, radiation. So a lot of the roles. So and this is one of the mechanical properties, and still now, so I'm not so much, but I'm now focusing on some permeability, hydroconductivities, and self-sealing, and the radiation, retardation of radionuclide like that. Okay, yeah, a lot of the, and this role is changed by stage, and the setting of the containers is like that. Firstly, this like that, and the unsaturated conditions of the material. So and the unsaturated soil mechanics is very needed. It's a very important academic issues. And the low permeability, swelling, and the condition is highly decayed temperatures, highly decayed, affecting some around the temperature is some 100 to 130 centigrade like that. Okay, so we have to consider the high temperatures. Okay, and the submergence of the buffer material, maybe some 10 or 100 years after. So I'm not sure unsaturated or almost saturated conditions of the bentonite and the decayed heat, and so what I say, water's heating influence to the bentonite material. It's very interesting for geotechnical engineering areas. Okay. And the erosion of the waste containers, more than maybe 100 years after this vessel, so human-made material will be eroded. So and we have to consider that some metal ions and clay materials relationship we have to consider. We have to researching. It's also the very interesting geotechnical engineering, environmental geotechnical engineering, I think. And since leakage of the radioactive nuclide like that, yes, maybe yes, 10,000 years later. So permeability is a very important role at this time. Okay. So a lot of the research teamers now, there are a lot of the research teamers, especially the geo-environment and environmental geotechnics. Okay. And please having some interest to this project. And the new aspect for the R&D, so I have already saw not only the mechanical conditions for designing, but also so water chemistry, high temperatures and the thermal histories like that, and a very long term, for geological terms, I think, and a lot of the physical chemical phenomena. Okay, so and actually, so that new generation engineers can propose their own new aspect by themselves. Maybe it's my focusing on, but actually, so or new generation engineers can be or maybe more than me to develop the new research subject. I think new aspect. I think I hope that. Okay. And not so much time. So develop. I will briefly introduce development in my studies. I'm now focusing on the swelling and hydroconductivities properties of that bentonite. So and today's I will select these topics. And hydroconductivity is also my interest. And this is so I have no time to explain the details. So and if possible, so next time. Okay. So and we are now a lot of develops a lot of the experiment, and maybe some participants, my student now participate in this webinars, and actually, so the Waseda University, Waseda GeoLab members are very highly good talent to produce and developed and designing the new experimental practices. Okay. Yeah, this is a very primitive and primitive? Yes, fundamentals experiments like that. Yes, this is a new operators. New, yeah, this is not new now. In my maybe 20 years ago, so in my new. And actually, this one is now. I'm not sure, but Waseda University have maybe around like that test equipment, some 50 equipment, I think, like that. Usually not always to develop the new equipment and apparatuses like that. And producing a specimen like that, this is a bentonite rocks on the small size. Okay, and so this is the experimental, a lot of the experimental data, and we are now developing the what I say, so a database of that many kind of around the 13 kind of the bentonite now. Okay. So and also I have already experienced some water chemistry is important, and so and take out some waters, and yes, water, yes, and the SUS 316L mode. This is a very what I say, very strong to erosions. So and we can use that. It's a very high expense vessels. And one of the ion chromatographies, we are now investigating some water chemistry also. Not only the ion chromatographies, but also some ICP and yes, Waseda University have what I say. So yes, a very chemical analysis centers we have. So and of course a lot of the technicians we have. So and we are now we can investigate some detailed water chemistries by using that facilities. Okay. And also we are now develop the prediction method of the swelling and the self-sealing like that. Sorry, so I'm not explain the details. So but the essence is one of the new equations of the evaluating the relation between the swing deformations of the compact materials and the governing factors of that behavior, some mormonite, smectite, clay minerals behaviors. So and actually, so observations apparatus also we using that scanning electron microscope, special scanning electron microscope like that. Yeah, this material, this apparatus, this microscope can be observed the relatively observe the water drops, water molecules like that, and we can find some observation of the ventral swelling like that. Yes, this same part, same positions, and after water coming up, some this void will be filling up by the swelling the ventilate material like that. Okay, and from that observations, so we can make some image of the swelling process like that. And yeah, I'm now using I'm using some mathematics calculus, and so we developed and proposed a new parameters, physical parameters of that, like that, and the swelling model of the mormonite. Yeah, this is a geotechnical and colloid chemistry's collaboration like that. Okay, and the essence two is yes, pour water's effect. Yes, water chemistry's equations and specific surface of the bentonite like that. And the essence three is some yes, we now compose some new equations, and the theoretical equations are now developed like that. Okay. Like that. This is my total is some image prediction of the swelling, but very complicated. Sorry. So I have already published the Journal of Geotechnical and Geoenvironmental Engineering (ASCE) like that. Maybe not open access. I'm not sure, but if I contact me, so I will send this papers. So please read to understand the detail of this project, prediction concept. Okay. Okay. And after then, so like that, it's a very what I say, equations, mathematical conditions like that. Okay. Sorry, I'm not so much time to explain. Okay. Yes, but the point is not only the geotechnical parameters, but also some colloid chemistries, clay minerals, and water chemistry. Yeah, so romantic research, I think. And yes, and we can check the validity of this prediction, calculated result, and experimental result compares. Okay. Yes, this is like that. Okay, I will. And also, yes, and actually, so utilization of the prediction, so we can design the size, dimensions of the buffer like that. Okay. So additional information is that, yeah, we are now also develop the hydroconductivity theoretical equations next time, and like that. Okay. This also that some ASC's journals we can published. Okay, like that. Yeah, please this one. Yes, this skip out. Okay, and the model test also we are now doing that. Yeah, this part is some apparatus is what I say, make some boundary conditions, modify this like that, and relatively large size compacted, and after then water coming and swelling and filling up some voids, gap like that, and how to select. Yeah, this is self-sealing. And the design method is like that. Okay. Sorry, so I'm not so much time to Okay, and yes, this is our we have a lot of experiments. Yeah, always developed like that. And the research achievement like that. Yeah, if please take a pictures and maybe you can reach it some my research maps. Okay, and some articles can be downloaded, I think. Okay, like that. And now Japanese government promoting now like that. Yes, this one Japanese government are now selected some part. Which area is better to disposal project? Okay, and now the Hokkaido areas is now candidate one of the not the two candidates now selected. Okay. So and after them, I will finally. So I will show you that some future photographs. Okay. Yeah, but this is not features photo galleries of that research project. A lot of large research facilities we have. Like that. Yeah, this is industrial waste. Yeah, relatively shallow facilities like that. And we have to also educate new generations, new generations peoples. Okay. And the conclusions. Okay. Time is okay. Okay. So today my topic is I will explaining some. I was explaining the brief introduction of the situation of the nuclear power stations, and role of the bentonite buffers, and geoenvironmental subject I will introduce. Okay. Please find new geoenvironmental subject also. Okay. And I will, really so brief introduction of my research. So, and I believe we can make some change showed by the photo galleries. We continue to contact each other. Okay. And finally, so like that, this is the total whole of that facilities image. And this is the surface facilities. And inside the vessels facilities, and yeah, it's a very exciting facilities. Each is the tunnels and the pits like that. Okay, and a great project in all of the world, I think. Okay. So and so, thank you very much for your attention to my lectures. Okay. And a lot of the people are now joining this project. Okay. Sorry, so I'm not fully times I spend. Okay. It's over on my presentation. Thank you very much.
Excellent. Thank you so much, Professor Hideo. So you see, I am asking everyone to type their questions in the chat box.
Okay.
So hopefully that way, you can read them and answer them. Do you see some questions in the chat box?
Yeah. I'm now checking some. First one is yes. Hello everyone. This is from Christmas.
I think you're
okay. Next one. How the site storage was selected. Soil characteristics required. Okay. So maybe soil characteristics of the surrounding the ground. I think. Yes. Yes. For example. Yes, from the viewpoint of some aspect, yeah, it is very important to select from the viewpoint of the aspect of the hydraulic conductivity of the surrounding ground. Maybe a rock material. So and is it all right to these answers? And of course, stress direction is not so complicated conditions like that. So it's a very, but actually that from the political issues, it's very difficult but actually the soil and the surrounding ground characteristics are very important to select the site storage. Okay. And next one is container is canister containing vitrifications made of the metal or any okay. This is now is some Japan is some iron material and using some chitan, you know, chitan, and some copper also selected. All right. So and also from the metal engineers are now developing the new canister, new and suitable canisters containers like that. Okay. But any special material? Yeah, metal and the copper, stone, and but iron is most like that. Okay. Next environmental. This one. You sorry. This one. Thank you so much. Very interesting webinar. Thank you very much. How was the 300 meter holding cells constructed without
Cave-ins.
canes? What's canes?
Without cave-in.
Okay, I understand. Yes, this is also the very important and the interesting developing point. Now, yeah, not decide, but one of the, you know, some tunnel boring machine, you know, TBM, tunnel boring machines,
Okay.
and using some not method, you know, and new Australian tunneling method.
Hmm.
You
Is it
understand?
shoring? Do you do shoring? Like use metallic piles, sheet pipes, or something like that?
Yes. Like that. Metal, I'm not sure, but not only the metal, but some concrete, very high strength concrete cells like that. Yeah, this is one of the developing point from the tunneling engineers.
So
All right.
there are other questions, Hideo. I don't know how much time you have because it's already 1 a.m. for you. But I request all the attendees to type your questions in the chat box so we can also, you know, direct the questions to everyone or to the speaker.
Okay.
So I think some of the attendees are sending comments to me instead of me. Please send the comments to everyone or, you know, to the speaker so that everybody can see your comment and also the speaker can see it. If you send directly to me, you know, we may not be able to see it. But I think, you know, Hideo, Professor Hideo, I think, you know, your presentation is extremely useful. I learned a lot of, you know, new stuff, some basics, right? You know, how high level nuclear, you know, waste is disposed. I think your slides and your explanation was so clear. Now I could comprehend, you know, how they are disposing because when you attend the presentations on, you know, this bentonite buffer material, you know, when you go to conferences, you attend these presentations on bentonite buffer, but you don't get the good picture of it. I think, you know, everybody who attended this webinar will appreciate, you know, the geo-environmental challenges. Right? You know, a lot of geo-environmental researchers or geotechnical researchers, they deal with bentonite, but the bentonite as a buffer material for high-level radioactive waste is very, very challenging, as you pointed out.
Yes.
I think, you know, there are a lot of research opportunities. You know, a lot of times if you talk to people, you know, I mean, a lot of people are dealing with energy issues, right? Energy is a big issue worldwide. And, you know, as a geo-environmental engineer, you think, oh yeah, energy, you know, I have nothing to do with it. But, you know, we have a lot to do with it because if you know, nuclear energy is considered as a clean energy because, you know, it does not emit any greenhouse gas emissions. It doesn't have greenhouse gases because from the climate change point of view, they think this is the best option. But, you know, the problem is with this creating the radioactive waste, how you dispose it off. So that is itself is a very big challenge. And, you know, always say that the geoenvironmental engineering field is the emerging field, and there are so many opportunities to do research and make the difference. It's not just the research to publish papers, but actually, make the impact in practice and on the environment and people's lives. So I highly recommend reviewing the papers by Professor Hideo. He pointed out some papers. He had also given the link to go to his website. But feel free to contact him. He's a very personal person. He will be happy to help you. And just the other idea of these webinars is to make some connections with the potential collaborators. So now you know that somebody who works on bentonite buffers, bentonite sand mixture buffers under challenging environment, high temperature, saline conditions, all kinds of interesting things are involved in this one. So it's such a challenging topic. I mean, it's not easy. It's a very, very challenging topic, and he does a lot of experimental work. He does a lot of, modeling work. I know I attended his presentations. I couldn't understand any of the equations that he was showing, but he does a lot of fundamental research, in terms